As we continue on our series within a series, the building and construction of the first underwater tunnel in North America, the St. Clair Tunnel, we left off in our last video the installation of the iron segments that formed the rings that formed the tunnel. On April 7, 1890, the shield finally passed under the river, a distance of 1,716 feet from the portal of the tunnel. It was at this point that Chief Engineer Hobson introduced the use of compressed air. Hobson was criticized for not using the compressed air earlier. This is what was published in the Journal of Civil Engineering and Construction, a publication that was made available to his engineering peers. Hobson should have used compressed air from the start of tunneling, given the soft, unstable nature of the clay. Before Hobson used compressed air, the volume of clay removed from the excavation was 50% larger than the volume the tunnel occupied, because clay oozed into the workings from the sides and top. Once Hobson used compressed air, this discrepancy practically disappeared. So what they're saying basically is Hobson caused the workers an awful lot of extra work, because they were actually taking out more clay than they should have been. Some of these workers were quite innovative. One digger, John Ordowski of Port Huron, invented a tool that replaced the ordinary shovels used to dig the clay. A knife-like device with handles for 2 men would cut a slice of clay roughly a yard long and several inches thick at a time. Tunnel supervision couldn't figure out why this guy was going so far ahead of the other guys, and they looked and saw this tool, and they made sure that all the workers had this tool. I don't know if you ever tried to dig into hard clay with a shovel, but it's a lot of work, and I can imagine that slicing off pieces of it would have been much faster and easier. It would have been a tool similar to the one pictured here, only much larger. Hobson had built 2 small outbuildings, one on each side of the river, to house 2 Ingersoll Sargent rock drill compressors. And this is a company out of New York, and they supplied the compressed air to the workings through a 6-inch wrought iron pipe. One of the problems with compressed air is that both man and animals had to get acclimated to that air pressure, and so they would enter the tunnel through an airlock that regulated the air pressure from one to the other. This photograph here was taken in a tunnel that no longer used horses or mules to carry out the clay. The St. Clair Tunnel had to use an airlock that would accommodate not only man but also the horses and mules. And like I said before, the horses didn't do well in the compressed air, but the mules did. Hobson built solid airtight bulkheads of brick and cement mortar 8 feet thick across the tunnels. At either tunnel heading, men, horses, and cars passed through one of the 2 airlocks, each 6 feet in diameter and 17 feet long, with iron doors. Each airlock encased one of the 2 sets of tracks running the length of the tunnel. They also built a small airlock measuring 10 inches in diameter, but 25 feet long, into the bulkhead to allow long pieces of pipe to move through the barrier. In this photograph here, you see the men lined up waiting to go into the airlock. Originally, the airlocks had a single 4-inch globe valve to equalize the air pressure, but this allowed too rapid decompression and caused many cases of the bends, more commonly called the benders by the men, because their knees would buckle and they would bend over in pain. The men would frequently bleed from the nose, mouth, and ears. 3 men died of the bends during the tunnel project, and scores suffered from the disease. In time, they substituted a 1.5-inch valve in the airlock, slowing the rate of decompression. But even with the smaller valve, men would pass through the airlock in about 2 minutes. Once again, the engineering news was critical. It is believed that extending the decompression time to 5 minutes would eliminate most of the cases of the bends, but conceded that this might slow the pace of the work. The number of workers in the compressed air zone at any given time was between 50 and 75. So I'm inclined to believe that they could have avoided some of this problem with the bends had they given them more time in the decompression chambers. But it would have slowed the work down, like the engineering news said. The American shield ran into quicksand on May the 5th, 1890, and water began flowing into the tunnel. Supervision was notified outside of the tunnel, and what they did, they increased the compressed air pressure, and it quickly stopped the leaks. So what did these hard workers in the tunnel get paid? Well, there's a couple of conflicting sources, but I think the closest one would probably be from the Engineering News article of February of 1890. They claimed that the diggers earned 17.5 cents per hour, the iron men 15 cents, and all other labor 12.5 cents, all for an 8-hour day. Both the Canadian workers and the American workers petitioned for higher wages. They wanted 25 cents per hour. But the tunnel management simply ignored the demands. Once the use of compressed air stopped in early October of 1890, the tunnel company reduced wages to 12.5 cents per hour, but allowed the men to work 14 hours a day to make up for the lost earnings. The two shields advanced toward each other at a pace that generally improved over time, after an initial learning process on both sides of the river. The monthly progress shown in this table that you're looking at shows that the American shield excavated nearly 700 more feet of ground than its Canadian counterpart. This discrepancy reflects the 2-month delay in starting the Canadian shield, the poor performance in the Canadian heading in May of 1890, and the more difficult ground encountered in the Canadian excavation. As the two shields approached each other, Hobson stopped the American shield from advancing, and on the 20th of August he began a 6-foot drift line with timbers through the remaining space of roughly 125 feet. He did this to allow one final check of the tunnel alignment to allow adjustments before the shields touched. The Canadian shield continued to advance, and at noon on the 23rd of August, the shields were only 89 feet apart. The next day, when only 15 feet separated the men in the drift from the American shield, someone bored an auger hole through to the other side and passed a plug of tobacco through the opening. Workers removed the remaining clay in the drift, and at noon on the 25th of August, Hobson passed through the opening from the Canadian heading into the American side of the diggings, followed by his chief assistants and other tunnel company officials. The leading edges of the two shields finally met on the 30th of August, 1890. But the tunnel company needed another month to complete the tunnel lining. They left the outer shells of the shields in place in the blue clay, while they removed all the internal parts. The workers had to specially cast the last ring of the lining to fit the remaining space. On the 2nd of October, 1890, Hobson stopped using compressed air. The completion of the tunnel's long approaches, along with the construction of the portals, did not begin until Hobson was confident of the success of the tunnel excavation. The St. Clair Tunnel did not formally open until the 19th of September, 1891, more than a year after the shields met, and the first freight train did not use the tunnel until the 24th of October the same year. Even after they finished the lining, much work remained. The men had to remove the bulkheads, the airlocks, along with pipes carrying high-pressure water and air. There was a lot to be done. This is the pump house on the American side. Drainage of water from within the tunnel has never been a major concern because the tunnel itself remained largely watertight. After construction work ended, the tunnel company installed 2 steam-powered pumps with a capacity of 500 gallons each at the low point of the tunnel under the river bank on the Sarnia side. But Hobson had to design and build a more substantial drainage system to handle the large volumes of water that would collect in the bottom of the open cuts after rainstorms. The open cuts creating the approaches to the tunnel created a drainage area of 14 acres on the Canadian side and 11.5 acres on the U.S. side. On the American side, the tunnel company placed 4 smaller Worthington pumps in a building located on the south side of the open cut just west of the tunnel portal. That's this pump station right here. And they pumped water up to a drain located above the top of the cut. While we have this picture up, I misspoke a little bit earlier. I think I said cement blocks here. But you can see they're obviously not cement blocks, but they are the limestone blocks. And it's the same limestone that was used for the portal of the tunnel. As you can see, it all goes together quite nicely. This photo here, you can see the inside of the pumping station. You can see the switches on the left side and the pumps on the right hand side. Come and take a little closer look. And this is a pumping station in Sarnia, and they had basically the same type of pumping system inside their pump station as well, except their pumps are just a little bit larger than the ones in the Port Huron station. In the early 1800s, Baldwin Locomotive Works was in financial trouble. They had a hard time going through the early 1800s, even into the mid 1800s. But then by the time that the St. Clair Tunnel was built, they were the #1 locomotive industry in the United States. St. Clair Tunnel Company placed an order for 4 custom heavy-duty steam locomotives to move trains through the tunnel. Baldwin filled that order in February of 1891. Each locomotive had a 0-10-0 wheel configuration and were designed as camelback engines, so they could operate in either direction, and thus a railroad did not have to turn them around after each passage through the tunnel. Plus the fact that the cab was in the middle over the drive wheels gave extra weight on the drive wheels for better traction. They had the power to pull a 760-ton train up the long 2% grade at both ends of the tunnel. As the tunnel approached to completion, sightseers began to descend on the site. The tunnel company admitted a few visitors, but only with a pass signed by Hobson himself. In late November of 1890, Thomas Edison, who grew up in Port Huron, was one of the party of 10 who toured the tunnel. In mid-February 1891, an unnamed female reporter for the Port Huron Daily Weekly Times went through the tunnel, the first female to do so. 6 months earlier, tunnel officials had refused admittance to a female reporter from Buffalo after she began taking dimensions of the machinery. The opening of the tunnel created some friction between the Grand Trunk Railway and the forces of civic boosters in Port Huron, including the Port Huron Daily Times. The Grand Trunk scheduled the formal opening for the 19th of September to accommodate its president, Sir Henry Tyler, who was returning to England on the 21st of September. This was about a month earlier than the Grand Trunk had previously suggested. The Daily Times, for instance, had to rush a special tunnel opening edition into production a month early. The Port Huron newspaper had hoped for a great public celebration, including special excursion trains and parades and walking tours, all passing through the tunnel. Given the amount of work still unfinished within the tunnel and the continuous problem of landslides along the approaches, Hobson ruled out excursion trains or walking tours. The ceremonies and events surrounding the formal opening of the tunnel were largely private in character. The celebration of the formal opening of the tunnel began Friday, the 18th of September, 1891, and continued through the following day. Friday evening, the citizens of Port Huron hosted a banquet to honor Sir Henry Tyler and the Grand Trunk Railway. Over 100 attended, including all the principal officers of the Grand Trunk Railway and the St. Clair Tunnel Company, the mayors of Port Huron and Sarnia, the governor of Michigan, and other government officials. The formal opening took place the following day when a trainload of Grand Trunk officials and their guests rode through the tunnel from the Sarnia side to Port Huron. While we're looking at this collage, remember when we were talking about rolling that shield down that hill and wondering those 3 fellows were holding on to it? Well, we can see that that wasn't the case. Look at the cables and the wires here and the poles. That looks like a pretty complex system they had to control the descent of that shield. I found an article in the Sarnia newspaper telling about that inaugural train ride through the tunnel and where it departed from and so forth. I thought you might be interested in, and I'll read some excerpts from this as we go along. The Port Huron Dispatch, stated September the 19th, says, all the trains arriving at Port Huron and Sarnia have distinguished guests who were to take the first official ride through the Great Tunnel. These two cities never before have had the honor of entertaining so many men who are identified with the political and commercial interests of the American continent. Most of the visitors went to the hotels of the two cities and did not go direct to Point Edward to make the start with the inaugural train. And here we see the Point Edward station where the president went on. We'll read about that in just a second. They met the train at convenient points later on. At Point Edward, not much more than the usual bustle and movement was to be noticed. A special train with 4 ordinary day coaches was drawn up in front of the station. At 12:20, Sir Henry Tyler waved his hand and the inaugural train started. It pulled directly to the Sarnia depot, where a number of the invited guests and citizens of Sarnia were taken aboard. As we zoom in here, you can see that station. Then the train steamed out to the edges of the town to reach the approach to the tunnel. Here, near the unfinished depot, a triumphant arch had been erected. And that station that they passed, that was under construction on the way to the tunnel, would eventually look like this right here. And that triumphant arch looked like this. They would pass through this arch, through the tunnel, and then go through another arch very similar to this one in Port Huron. In our next video, we'll take that train ride through the tunnel and we'll see the arch in Port Huron. Join me then.